Hi, this is a Nikon D5 that is exactly the same kind of camera that the astronauts has at the ISS, and I'm going to show you my favorite configuration for this camera in case some astronaut can see this. And as it's not the most common configuration, I'm going to explain a little bit what we have here. Here we have the Nikon D5 with a lens that is very luminous. It's an 85 millimeters 1.4, so, and this if you see is one of the most luminous possible lenses with the highest resolution, because the diameter, you can see how big is the diameter, rated with the focal length are very similar, so that makes one of the most luminous lenses that is possible to make because of the size of the sensor. Now with other sensors is even with larger sensor is easier to make more luminous images, no lenses. I'm going to show you also how we'll prepare if it was at the ISS. First, obviously, always try to put manual mode. We press mode and we change to manual. Then we put obviously the largest aperture possible. We have to focus manually and be very careful. But good thing here is that we can put it in infinity. But we should double check even with some pictures that is focused properly, because we don't know if the window of the ISS will impact the focus. So, but at least we have this that is quite smooth. But as said, as we are opening the shutter a lot, we have to be very careful. Then the ISO is not so critical, but for example, the images that I have as reference have 12,800 ISO. If maybe I would prefer a little bit less, but this is the reference image that we have. The shutter speed 160, and then because this will give us the information of the lights of the cities very sharp, but not the information from the background that has a lot of interest for researchers. And this is a very sensitive camera. We are going to introduce bracketing. Bracketing is a feature that the camera has, that once you take one image, the next image is changed the time exposure automatically. So for example, now we'll take an image with a 60th and now with an 80th, with a much longer time exposure to get this diffuse light that I mentioned. Obviously, for this, the ideal will be, and then we press again and we go back to 60. Then what we need to do is program the camera to take interval shooting. We will set up the start options. We can choose a date and time. For example, if we know that we need to wait like 10 minutes to pass over Madrid, no? So we'll go and put the date. Always the astronaut has to be very careful that double check the time on the camera is properly set up, because if not, then later is very difficult to find out where the images are taken. So we'll go here, we change the here there's something wrong for this case with the exposure. Smoothing should be off. Then start up options, let's say now, and what is that? Interval shooting, here setup off, number of intervals as much as the camera can, 2 images per shot. So we take the bracketing images. Okay, interval. Now this 20 seconds probably will be enough for the ISS, but that will be interesting to check because to see, and the ideal is at least a 30% overlap between images, and obviously pointing nadir, and then start. Now it's on, and as you see, and you will hear, 20 seconds. To get closer so you can hear it. And take 2 images. I'm going to open the camera. Probably we are going to be we're going to saturate, and when you are tired, you turn off and on. And here we see, well, we are saturated because here we have a lot of light, but you see that in the same, with very little distance, there's these 2 images that we can see with the background, no, with the histogram. And this is it. I hope some astronaut, maybe Pablo, will be able to see and take images like this, time lapses, pointing nadir with this configuration in the future.